if we've got a certain amount of water at the minute, you know, is there a way in which we could sprinkle it over, you know, because what's going to happen is the rain comes down, we're just going to start getting flash floods.
Yeah, that's what a lot of people are worried about.
So if we can somehow get that land, get it wet now, utilize some of the water we've got in the reservoirs to start doing that, you know, it's almost like saying, yes, we've got a hosepipe ban, but we know the rain's going to hit heavy in the next week. So what we need everybody to do is start watering their garden. And farmers, you need to start watering your fields.
Hello, and welcome back to Supernova Labs. This is another one of the interview segments we've been running over the past few years. And today we are graced by the presence of John Knott. John Knott has been coming along to some of the Open Space Meetups we've been running in central Manchester and has been building his own startup as a result of it. John, welcome.
Hello.
John, do you want to give us an idea about what you're doing and like what your backstory is for like what you've been doing over the past year?
Okay, so the last year, I've been looking at using Earth observation data from satellites or various other sources to help with a particular project for one of my existing customers, which is in the area of biodiversity net gain, looking to see how the data can help them automate what they do and also enhance their information so that they can make better decisions to help increase biodiversity across the country.
Yeah. So, like, just for people that may not know, it's maybe the very first time seeing a space video. What is EO? What is Earth observation?
So, Earth observation is basically there's a variety of forms of data, so which typically come from satellites, but might come from drones, high altitude planes, and even ground sensors. It's a combination of optical imagery, so photographs taken from different angles, different heights, although ultimately the optical imagery can struggle with seeing through clouds or with sunlight, shadows. So if you take an image from not high enough, the angles can cause distortion, etc. But then there's other ways of collecting the data. So there's synthetic aperture radar, which is called SAR. So the satellite transmits microwave pulses to the ground and then back up and takes measurements from that, looking at the backscatter. So going back to almost World War II, that's effectively how we used to detect submarines under the sea, was via those sort of signals bounced up and down. So that's that idea, but up in space. And then there's other forms of optical imaging, which can see through clouds. So lots of different contiguous bands, which can various different use cases for each different band. So there's an infrared band, for example, which can then be used for specific chemical and biological signatures. So, and those who remember back to their chemistry might remember that different parts of the spectrum show up differently. So those can be used to detect those, so the gases and so on. All of those come together under the collective of Earth observation data.
There's like some really, really crazy ways they have to collect Earth observation data. So you were talking about the cloud cover, for example. There's specific orbits around Earth that come back around at 10:30 every morning over the same site. So yeah, it's like the minimum cloud cover to get these observations.
Yeah. So there's different. Yeah, and there's different heights of the satellite. So you got there's the low Earth orbit, which is the LEO. So those tend to be higher resolution, and you get frequent revisits. So that's where a lot of the commercial data lives. Then you've got your medium Earth orbit, which is wider coverage per pass. So if you're looking at the bigger picture, The medium Earth orbit can be used for that. So often that's for navigation and some Earth monitoring. And then you've got your geostationary orbit as well, where generally the satellite stays above the same point all the time. So that's good for continuous monitoring of the same region. So weather is a good example of where you might look at that. There's also in very recent times, very low Earth orbit, VLEO. And interestingly, I've spoken to some people at Manchester University at a recent space day. They're looking at with the VLEO. There's a startup, I think they're called CASA, CASA, who effectively, because the lower orbit you are, the more drag you get. Mm-hmm. So they're looking at reducing that drag, because if the drag on the satellite will cause friction, which will mean that the satellite is less likely to stay up for very long. And I think what they're doing is looking at reducing that friction, because, and again, by being lower, they've got even better resolution.
Fabulous. I mean, like, you're now in the Earth observation data market.
Yeah,
it's like an enormous market. I don't know much about the stats for the data market and how that whole thing works, but it's not so much the case of sending things up there for exploration anymore. It's sending things up there that are able to produce data, then sent back down, that has a use case on Earth, and there's a value to that, as you're saying. So, like, what got you into it?
So I've been a systems developer for over 30 years. During the .com boom, suddenly grew the company to being 4 of us to 50. Sort of start to think, I don't actually enjoy having other people working for me. I kind of do my own thing. And although it's quite fast, I mean, I really enjoyed the industry. I loved working in the restaurant industry. We were working with some of the top chefs in the country. Yeah. It's very reminiscent at the minute with AI, that everything if you want investment, it has to have AI. Yeah, back then, you wanted investment, you have to be .com had to do some sort of thing. And it's interesting parallels to now, because I think a lot of the infrastructure wasn't quite in place at the time. But then there'd always been this desire to do, I think, something in the space industry. So I went along to Factory International. Alan Cross was doing some interviewing. There was Anushka Sharma, yes, and John McFall. There may have been someone else, but I can't remember. So John McFall, fascinating guy, basically Paralympian, who then in the Beijing Olympics, he won a medal, became a trauma surgeon, and then, not content with that, he then decided he was going to train to become the first paraplegic astronaut. Mm-hmm. So met him. He's actually going to space next year, I think it is now, with the ESA.
Oh, this guy's name, brilliant.
And also there's Anushka, who is very very encouraging for anybody to get into the industry. I came along to the Open Space networking event, and thought, I was just thinking, how do I get into this? And then just stumbled upon somewhere a space data course. And I thought, oh, well, I know data. That's my thing. Making sense of data is what I do. Maybe this is something I can learn from. So I attended the course. That was a University of Edinburgh remote course. Attended that, and then I started, was doing the course. I thought, what can I actually do with this? And I've been working with a customer for about 6 months by this point, they're ecologists, landscape architects. So I thought, can I do something with this in the sustainability, give something back to the planet, so to speak? And again, I was having a conversation with Emma, and she was like, oh, I oversaw this MBA on biodiversity net gain. I was like, oh, Tyler Grange do that. So, right. So it kind of just spun all from there. Really. So yeah, long-winded story, but basically it just sort of, something just fell into place at that moment. From a technical point of view, I think Earth observation is right now is a really, really interesting time. Things like the UK Earth Observation Data Hub going live, which is government backed. And it feels as if with the combination of we've now got with the more and more companies putting the satellites up there with the accuracy needed, Plus, there are government incentives to get involved in Earth observation data. It just feels that now is a really, really fascinating time to get into this market.
Well, I think that's what's been really interesting for me, because I mean, I've been having conversations with people over the years about in the UK space sector about, well, how do we bring data scientists into the field? Because as you were saying, like, all of the work has been around AI and managing like tensors and data sets through that. It's not dissimilar to what is going on in Earth observation, and it's nice to see such an overlap between the two, because for the longest time it's been for military data, right? It's been military data, it's been sighting data on the battlefield, and like getting the high ground and getting the best observation you can. But now you're seeing more and more like peaceful uses of the data, such as like we have for farming, for disaster relief.
Yeah, so I mean, the Earth observation data market in the UK is expected to almost double between 2025 and 2030, going from about $1.13 billion to $2 billion by 2030. It's interesting you say defence, because actually the biggest share of that is agriculture, which is about 25% of that market.
Really?
Yeah, so and defence is actually quite a small, well, not small, but it's significant enough, but it's high value when you get involved, but it's not, as a proportion, it's relatively small. It's relatively, more like 10-15%. You got disaster management, which is 17% of the market, urban planning nearly 16%, and so defence is at the moment just under 10%. But historically, that's where we get the Ordnance Survey maps from, is defence, for example. So,
of course,
lots of use cases coming along for this, and there's business cases being generated by government interest in utilising the data.
Yeah, John, you've been building this platform over the past year. Like, I've been talking to you while you've been coming to these meetups, and just been really great seeing it growing and like the idea forming into something that's tangible.
The specific case we're looking at the moment is to do with biodiversity net gain. Any property development of a certain size has to demonstrate a 10% biodiversity net gain. So currently that requires quite a lot of ground truth surveys. So ecologists will need to go and do that. And this is a 30-year project. And I think ultimately there aren't enough ecologists to properly monitor this over 30 years. My feeling is that whilst DEFRA, who oversee this, specify it's going to have to be ground truthed, what we've been looking at doing is how we can use the satellite data to help automate the processes to add additional information in. So some of the ideas we're looking at is, one of the simplest is, at the moment, how do we take the image of these fields, water, quarries, etc. We need to turn that into polygons. So we've written something that will work out the shapes and map those, so that those can then be used in the reporting. What it can be used to tell you is something has changed, something significant has changed about that area. So that might provide a warning signal to the company to say, okay, so you're 2 years into your BNG change here. Something's changed. Someone needs to go and look at it though. So tools like that to help make this work on a grander scale.
And how far along are you in that process?
We've kind of got an initial prototype, but to turn it into a proper proof of concept prototype. So looking to up the technical readiness level from being about 3 to about a 6 or a 7. So hopefully over the course of a year, take us to pretty much being ready for the market.
Wonderful. And like, have you, if there were developers that were watching this, like, what would you want them to know about this platform, and how can they get in touch with you about it?
From a property developer point of view, they might say, oh, here's this land. We might be able to, someone could improve the biodiversity of that. Now, if you have to say, well, before you even start, you're going to have to get an ecologist to come along and do a load of surveying. That's quite expensive. Whereas again, the satellite data could give you an initial assessment and say, yes, you could do X, Y, and Z with this. Here's a basic overview of what we think could be improved, or the improvements could be had, so that you can very quickly get an idea as to where would be potentially viable. But we're also talking to, for example, Yorkshire Water Trust, because they're looking with their land that they have, they would then look to improve the biodiversity of that, so that they can then sell it, that improvement, to the developers.
Fascinating, because I mean the thing is, like, that I was talking to a project locally here in Manchester that is looking at rebuilding peatlands, and one thing that I think has come out of the past summer here is that they spent, I think, maybe 5 or 6 years rebuilding these peatlands and wetlands, only for it to burn in wildfires.
I suppose, yeah, there's a bit, because there's a bigger picture that, so for example, with there are companies out there that they're using drones to identify the water flows in areas. They're mainly aimed at agriculture, but yeah, if you're looking at the peat, normally what you do is you try and stem the water so it doesn't rush off too fast, thus washing all the peat away. But what you might need to do is, again, with the satellite data, you can look at the wider picture. So you've just done X, Y, and Z to this land. What's the bigger picture? Is there some unforeseen effect that you're having? You're actually monitoring that what you've done is actually having the effect that you're hoping to have, which is to maintain and restore the peatland. Because you mentioned the wildfires, and I think from memory, well, first of all, the wildfires are terrible because there's a lot of ground nesting birds that specifically, there's only certain places that they nest on the moors, and they typically will return to the same places. So there's that aspect. Obviously, there's from a human point of view, we want to enjoy that land for future generations. There's also the more immediate danger, which is the smoke inhalation for many people, and it takes, if memory serves me right, it's about 10 years after a fire for the land to actually be restored.
If it's going to be more regular that we see less rain over the summer,
we're in a peak El Nino this year. What we're not quite sure of is what the knock-on effect will be for the European winter. So an El Nino is a specific warming of the Pacific Ocean.
That's quite far. It's quite far away from us, though, right?
Yeah, but it's one big planet and has an impact on the planet. So one of the potential impacts that has been seen in the data is when there's a particular peak El Nino event. This impacts the jet streams over the Northern Europe, which can have one of two effects. Either the Arctic winds come lower, which leads to a colder winter in the UK, or it can lead to a much wetter winter, which, funnily enough, might be what we need right now. This planet, believe it or not, we're not got this discrete zone here and this discrete zone there. It all works. It's one big system.
Yeah. Well, we draw these arbitrary borders and then believe them to be real.
Yeah. Funnily enough, the weather systems don't recognise our country borders.
Okay, interesting. I mean, and John, you're the coalface of this whole thing. You're the guy providing the analytics for these companies and for these governments to work together and gain the analytics so that they can combat this kind of thing and maybe improve the biodiversity in the process.
One of the things I would say to many people who they might be thinking, oh, how can I make use of this Earth observation data? Look at your use case. There are many use cases for what Earth observation can be used to do. In health, there are ways to track diseases, how they're spreading. In agriculture, you can look at the health of crops, looking at the health of trees and vegetation. Ocean uses, so you can detect the health of the seas around the country. Lots and lots of different uses of this, depending on your particular sector. Data is there. It's going out and finding your case for using that data. One of the things I learned in the footfall industry was that so this is counting number of people. You detect objects, people, cars, etc., in and out of shopping centres, high streets. The weather was always a massive guide as to where people would go. So good weather, people go to the high streets. Bad weather, they go to retail parks, shopping shopping centres, etc. And you could see the impact of the temperature is huge. So when you were comparing this year or the previous year, often you would not just look at the previous year, you'd look at 2 years back as well, because you wanted to know. So, for example, there was one day, I think, basically it was in March. I can't remember which year, but it was a March day, and it was an incredibly sunny Saturday in the UK. But the previous year we'd had snow. So the temperature difference between this same day was, I think it's 25 degrees centigrade.
Blimey.
And the difference in the data was huge. So if someone was just looking at that as being their evidence base, that wasn't very good to do.
And the thing is, over time, if you can see these flows of like how people are moving based on weather, like how the climate is changing based on historic data as well.
Yeah.
Like it opens up the opportunity for analytics as to like predictive analytics as to, okay, well, what given a certain state, like what could you expect in future?
Yeah. Yeah. So you could hopefully try and predict what might happen next. For example, this year, like you mentioned about the water before, and we don't have enough at the moment. How do we target that water better? How do we target that the best way? One of the concerns at the minute, for example, is that because of this period of drought, the ground is incredibly dry, and water
meter down, it's completely dry.
Yeah, and water won't absorb into dry ground very well. So, funny enough, we need the right kind of rain to fall. By using observations as to where that water runs, maybe what we could actually do, do you know what, if we get clever enough, we might get to a point where we think, do you know what we need to do is we know that the rain's about to come. What we're going to need to do is we need to wet that land first, because that's going to help us. It's all kind of very, very advanced.
Fabulous, John. And like, just to finish this off, like, John, like, why do you want to do this? Like, what's driving the whole thing?
I want to leave the world a better place.
Yeah.
I think it's on each of us to try and leave the world a better place than we found it. And I think one of the things I could do is using this data to try and improve the biodiversity of this country. Maybe gain a better understanding as to how the weather patterns impact us. So that's the aim.
Fabulous, John. John, I'm so grateful for you coming along today. Thank you so much. Like, we have had you speaking at the Open Space conference, but wanted you to come back and talk more about what you're working on, so we can put it more out into the field and showcase the businesses that are growing out of the meetups and the conferences we've been running. So
I'm grateful for the open space community, because it's by having these conversations that things start to work in your mind, and getting them out there and road testing them with people, and just it's been really enjoyable.
Wonderful. And if people want to get in touch with you, how would they do that?
Probably find me on LinkedIn. That's probably the best way.
Fabulous. I'll make sure it's in the description for everybody as well.
Yep. Okay. Great.